speak about some hacking, right? So I leave the floor to Anand.
We are to start a Javascript talk with a slide that's titled the quality of government data. But that's where the problem begins. See, a couple of years ago, we were in touch with Arjun and Geo. Told us about this. Told us about this total sanitation program. On which the government has been spending something like 3,500 crores. Make sure that everybody's got a toilet, which is a fairly important problem. Now, 3,500 crores is about, and they've been spending it over all the years. There's been a bit of tracking going on around this. There is one particular site, tsc.gov.in, TSC standing for Total Sanitation Campaign, which has a lot of information about how the money is being spent, who's spending it, what they're spending it on, all kinds of stuff, and really, really rich data. And while all this data was there, we had some issues. On the one hand, for instance, on the one hand, we were hearing that the bulk of the country had gotten close to 100% coverage. And on the other hand, we were hearing things like there are 3.5 crore toilets that are missing. You know, that's a bit weird. And I'm going to show you how these toilets can actually be missing. The data in itself had some weird characteristics. Like, for instance, when you're looking at the tsc.gov.in website, there were pages every now and then that said data not found. There were pages where for several years, so for instance in Andhra Pradesh, the budget for the total sanitation campaign starting from 2004 to 2013 has been zero. But there's been spending going on against it. So either it's not been entered since 2003, 2004, or there's, I don't know what to make of it. Then there's the other problem, the problem of the other extremes. There are some of these pages where we look at it in the morning and look at it in the afternoon, numbers changed. And not just by a few crores, sometimes by a few thousands of crores. And there's this nice little disclaimer saying that the numbers are changing frequently because of data entry going on, and every now and then these things go wildly off. That apart, there are also problems around, so this is just what data is being published. And one of the things that Arjun wanted to do was to start tracking, saying, what are you publishing on any given day? How is this moving? Are you moving numbers up and down? Are numbers steadily increasing? Things like that. The other problem is what is a toilet. So this, for instance, is by some definitions a toilet. This has been reported as a constructed toilet in some district, and when people went to take a look, this is what they find. This is another toilet. Yes, it's sort of constructed, except that one can't really use this portion of it, can they? Here are a couple of other toilets out here. This toilet is certainly being used, but not quite as a toilet. And this too is being used again for storage. So the question of what constitutes the constructed toilet is varying. In some cases, if you've got half a wall, then it might be a toilet. In some cases, it's all there, but it's not really being used, but it's still a toilet. So all of these inconsistencies started coming up. So what we were doing with them was looking at, firstly, can we pull this data out and represent it in a manner which makes some of these errors glaringly obvious. I'm going to talk about the first part today by walking you through the tsc.gov.in website. So if you go to let's do this, tsc.gov.in, and they've got a nice little site. Actually, nothing little about it. It's quite vast. And once it loads, you'll see a whole series of reports. I'm going to show you one report first, and then come back to a list of other reports. So this is a financial progress report, for instance, that says that for each of these states, that's the amount of money that's allocated, of which some is coming from the center, some coming from the state, some coming from the beneficiaries, and how much of it they released and so on. This is a report at a state level. Now if I click in and drill down into one of these states, say Andhra Pradesh, I get the breakup of this at a district level. Now this information is available at state, district, and in some cases one level below that at a block level, depending on the nature of the data that's being collected in the report. Which is all very fine, except when you start trying to scrape this, we hit a simple roadblock. Notice the URL here. Now, I'm going to click on one of these states, and when I click, and the new result comes, notice that the URL has not changed at all. It's the same page. Okay. Okay, so is there some Ajax loading going on behind the scenes? Let's give it a shot and see what's happening on there. And you've probably seen pages like this on every government website in India has this kind of structure. So I click on Andhra Pradesh. No, it's not an Ajax reference. The page has actually reloaded. And the first item that comes on is this particular response, which is a post that we can do that. Move it a bit so you can see it. A post request is being made, and this request is being made to the same URL as we were on earlier. And let's look at the parameters that are being sent. So here's the form data. There's an event target which has something complex, there's an event argument, and then there's a view state, which is a bit long. Tell me how long it is. Now about 2/3 of the way. I think I was done somewhere there. Yeah. And then there's something else, event validation, which is something else. And then there's a whole bunch of other stuff. So at this point I figured it's going to be slightly difficult to reconstruct this really long parameter. Now, a lot of these ASPX sites have it. I will assume that Microsoft is not doing this out of malice. It's just the way their servers are constructed, that these URLs are built this way. If you go back to the original page and hover over the links, what you get at the bottom, for those of you who can see the link at the bottom, is that it's not really a URL, it's a JavaScript callback. It says _ do post back of CT $100 content placeholder $1 GB show blah blah blah. There's pretty much no hope of scraping something like this by pulling the HTML off of the URL and doing whatever processing one does. Name your language, it's going to be tough. The only way is to use your browser, do a copy paste of this data and put it into whatever spreadsheet you have. And doing that manually is a bit of a pain, given that there are 30 states, one page per state for one report, and there are several hundreds of these reports. And the objective here is to track how these change on a day-on-day basis. So obviously automated staking of some kind is required, which brings us to PhantomJS. And how many of you have used PhantomJS? That's a recent number, so you know that it's for those of you who haven't used it, it's a headless browser. Think of it as a browser that does not have a UI, but otherwise works exactly the same as a regular browser. Which is good, because then you can start doing stuff like this. You can write JavaScript programs that will open a page and do stuff with it. And what we will be doing is going to the TSC website, pulling stuff out and showing you output. What I'll do is give you a very rough idea of how that is done. Then I'll get into another line. So let's start copying this code. In fact, better yet, let me take one of the quick start examples out here. So firstly, to download PhantomJS and install it is fairly straightforward. You've got a download link, click on it, install it on Windows, it's just one executable, or it's just one executable. And what I've got here is is this reasonably clear towards the back?
Yeah.
So let's run PhantomJS, and I will get sometime a prompt where I can start putting in commands. And this is a standard JavaScript prompt, so I can see console.log hello, and I get a hello with a return value of 105. So not too different from Node.js, but with a few other features, like for instance, I could write a script that does this. Let me blow this up and talk you through the script, and then we run it. We begin with creating a web page. Now that's effectively the browser context. Once you've done that, you can say page.open, take a URL, and then to this callback function, the contents of the URL are passed. Sort of, not quite. You get a certain context. First, you get a status. And depending on the status, whether that's the HTTP 200, which is a success, or something else, which may not be a success, you can do stuff with it. Now, what this is doing is getting the variable title assigned as the documents type with something called a page.evaluate in between, which I'll come to in a few minutes. Let's just run this, and I'm going to unfortunately use WordPad because that's what I have on this machine. So we just use this code. I've defined variable URL, which is phantomjs.org, and then this will return the documents title. Then we print page title is phantomjs.org title. So let's save that and run PhantomJS. This file is called test.js. Network is a bit slow, so you may have to wait for a few seconds. Yeah, there you go. So page title is PhantomJS headless WebKit with JavaScript API. What you can confirm is the title that you get here as well. PhantomJS headless WebKit with JavaScript API. Now, what was that page.evaluate doing here? So, when you say page.open a URL, that opens a page. And then what gets executed inside is in the context of PhantomJS, not in the context of the browser part of PhantomJS. If you want to do stuff within the, so for instance, if you had a variable defined within the browser, and in every browser you have a variable window defined, if you tried checking if window was defined in this location, it would not be. But if you actually wanted the window, you need to put it inside a page.evaluate. So page.evaluate is a way of saying do stuff inside the browser, and the rest of it is the way of saying do stuff inside PhantomJS, not necessarily inside the browser. That's by and large the difference. Now, what we could do with this, therefore, is open a URL and then click on one particular link by using standard JavaScript triggers, and then open the next page, get the stuff out of there, go back to the previous page, and so on, right? Trouble is, you'll have within this callback a page.evaluate, within which you'll have a click, which will have a callback, within which you'll do a page.open, which will have a callback, within which you get the idea. So callback here. Node.js has its own solutions for it. Casper.js is a reasonably clean solution that is aimed at scraping. So what it does is gives you a way of getting out of this callback hierarchy, and gives you some ways of, give you some commonly used functions that are useful in scraping. So let's move to Casper.js. I guess you can figure out the reason why we Casper came about. Casper, like the phantom, is a ghost. Why that's a ghost who walks, this is a ghost that flies. Now, you can download Casper.js, install it, and we'll walk you through a quick start on Casper.js. So, you start by requiring Casper instead of PhantomJS, and then you say Casper.start, go to a particular URL, inside which you can use something like this.echo, this.getTitle. These are functions that Casper.js provides on top of what PhantomJS offers. And then you can say, then open this particular URL, echo this title, and then Casper.com. What this will do is, let's run it. Save it. Casper.js. So that also is the Casper.js web page. The first thing it should do is echo the title of the Casper.js web page. So it's done that, and then it should open the PhantomJS web page and echo the PhantomJS title. Now, two things: no nested callbacks, or at least no more than what one cannot avoid. And you've got a few convenience functions like this.getTitle, etc. Personally, I've only really seen the need for one of these functions, which is the .then. What that does is, you say something .then, it will by and large execute it after the previous command is executed. So it converts what is an asynchronous series of functions into a synchronous series of functions with a little bit of reasonably transparent magic going on behind the scenes.
JavaScript promises. The same thing as JavaScript promise, right?
By and large, yes. The implementation behind it is slightly different than what you would see in, say, jQuery promises, for instance. But functionally, yes, that's pretty much what it is. This is not what I should actually, maybe I will show you this. So what we did was build a bunch of scrapers. You can find the source code for these in github.com/argyem, under which there's a project argyem-scrapers. So this has two parts: the scrapers themselves, which are under the master repository, the master branch, and the website which uses this data and shows the results. That is in the GHPages repository. I'll show you what the output looks like and some of the insights that come from that. Then I'll dive back into the code itself. So, one of the things they were curious about is how much money is being spent on rural sanitation. How much money is being spent on rural sanitation across all the states. So, the size of each of these boxes is the amount of money that's being spent by a state. So, the amount of money that's planned for each of these states. So, a lot of money is going to Uttar Pradesh. Slightly less for Bihar, a lot less for Gujarat, not much for Meghalaya, and then there are these other tiny states or union territories. The color is how much money of this they have spent. So the deeper it is, the more money they have spent as a percentage of the plan. The assumption here is that if you actually spend the money, it's good. Right? So we will go with that assumption. So Uttar Pradesh in that sense is doing well. They're spending a lot of money. Bihar is not spending enough money. Andhra Pradesh is somewhere in the middle. West Bengal and Pradesh are kind of okay. Karnataka, I'd worry about a bit. Rajasthan.
Is this balanced across like a relative size of the state as well?
No, it is not. By size, if you mean by population, no, it is not. By size,
Uttar Pradesh is generally a huge state.
It is.
So even the budget, even though the spending looks like a lot, there's a chance that it's not.
True. So if you're saying that on a per capita basis, is this higher or not? I would talk about the per capita allocation, basically the size, not the color. The color is merely a percentage out of what has been allocated, what percentage of it is spent. So, for example, here, Uttar Pradesh has spent 98% of its budget already. Whereas, I mean, it doesn't matter whether it's per capita or on an aggregate basis. Whereas Bihar has only spent about 39% of its budget. Punjab has spent only 9.5% of its budget, so not that much. Then one can drill down and see why this is happening. So at the next level, each of these are the districts. And Uttar Pradesh is doing a pretty good job of spending all the money. In fact, let's take this one. Badam has spent 134% of its budget. This one spent 116% of its budget. This one spent 126% of its budget. Yeah, excellent job. Except for Kanshiram Nagar. Now I don't know if you're familiar with the naming of Kanshiram Nagar.
VSP.
Exactly. Yeah. Oh, sorry. I'm not too good at politics. Who's the lady that heads?
Maya.
So Mayavathi's spiritual guru or somebody apparently is mentor, right? Is this gentleman?
Sorry.
So, unfortunately, though, Kanshiram Nagar, as you will see later, is pretty much the only spot in Uttar Pradesh where neither the money nor the construction of toilets has gone anywhere. So maybe she had something to do with it, or he had something to do with it. I don't know. In Andhra Pradesh, barring Srikakulam, the rest of the areas are kind of okay in terms of spending. Maharashtra, Raigad has gone on a spree and spent a lot of money. In Gujarat, Panchmahal has done a fantastic job of spending 1.5 times their budget. In Kerala, Alappuzha has spent more than 1.75 of the budget. So that's in terms of what's being spent. You get a sense of, yes, there is a state level spending, and that's what this looks like, while Uttar Pradesh is hunky-dory. Drill down and you get a slightly different picture. There are exceptions every here and there. The other thing one could look at is, fine, they're spending all this money, but where are they getting it to in terms of the number of toilets? So each of these circles is one state. The horizontal axis is the percentage of money that has been spent out of the budget. The vertical axis is the percentage of toilets that have been completed according to plan. So this diagram represents the 100% line approximately. Anyone who's above this line has completed more toilets as a percentage of the plan and spent less than if someone were on the other side of the line. Barring this one state, almost everyone else at state level seems to be doing okay. And the one state that has a problem is Uttar Pradesh. They've done a great job of spending. They've spent about 98% of the plan, but only constructed 96% of the toilets. But let's not be too picky about it. If one were to blow up Uttar Pradesh, now in order to get to that 100%, there's been a fair bit of spending, and there are a few people who've gone ahead and constructed about 130% of the toilets that are required. Fair enough, maybe that is needed in some shape or form. Let's take, who's this one? Punjab. Punjab has barely constructed any toilets. They're hovering around here, one a few here, but they're certainly not spending any money either. Either they don't need it, or they don't need the toilets, or Then let's take Tamil Nadu. Tamil Nadu is a bit of a mix. Mostly above the line, but a few are below. But that's because they are close to 50%. Any specific states or districts you want to take a look at? Consistently above the line. No, but not too close to 100%. Let's take one of the biggies. Let's take Gulbarga. Gulbarga is only constructed about 60% of the toilets, but used only about 30% of the budget. Tumkur at 35 and 61 and so on. Now, all of this is as of the 30th of June. Now, we have data for a few weeks before that as well. So, if I want to see what this data looks like for the 25th, let's take all the states. The 25th, the 16th, the 9th. You won't notice too much of a movement, and if you keep your eyes very closely on the screen, you'll see a bit of a movement. I'll play it again once they're all loaded in cache. So this is what it looked like on the 23rd of May. A week later, moved like this, or did move. A week later, moved a little bit. 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 I don't know if you're able to see the movement clearly now. There's a slight jump. Now the pattern of all of these jumps is consistent in the sense that they all move horizontally first. So they spend the money, and then the percentage construction of toilets moves up. Which is for a fairly good reason, in the sense that you spend money on partially constructed toilets, and the rule is that you don't report a partially constructed toilet as 0.5 toilets. So at any given point, in reality, there'd be several hundred or several thousand half toilets, but you're not supposed to at least report them. Of course, what does end up reported as a constructed toilet is a different story altogether. Speaking of which, in Chennai, for instance, the Transparency Chennai initiative, they did a study of the actual number of toilets. So they went to the corporation and said, look, I'd like a list of all of the toilets. They said, we can't give you that. Okay, why is that? Because we don't know where these toilets are. So who would know that? There are 19 wards in Chennai. You've got to go to the ward councillors in each one of those and ask them. Okay, we go to the ward councillors. They went to each of the 19 ward councillors who came back with strange responses. They said, look, it doesn't matter if the commissioner tells me to give it to you. I won't give it to you unless ward 17 gives it to you. Okay, so what was happening in ward 17 is pretty interesting. So, but they did finally manage to get a reasonable amount of data. They also did an RTA request and managed to get much of that data. And with that RTA request and the data that they got, which didn't match by the way, they went down to the field and counted the actual number of points. Now they have 3 sets of numbers. What the RTA says, what the councillors say, and what they actually saw. And you can guess which one was the highest. The RTA numbers were the highest. What the councillors said was somewhere in between. The actual number of points was significantly low. But with all of this going on, and this project is really about showing what's happening, what the inaccuracies in the data, etc. But what I want to focus on is just the code that does this grading. So on this site, I've given scrapers, there's this link, psc.gov.in. And I'm going to spend about 5 minutes walking you through a portion of one of these scrapers. There are scrapers for about 50 reports. I just shall give a start of these. The code begins at this point where we say casper.start and put in a URL. This is the same URL that I showed you earlier that has the financial progress of each of these. So inside this, what we do is start doing a this.evaluate, like you saw with PhantomJS. Casper.js does a page level evaluation, and inside that we are looking for one particular ID. Now, I'm doing a dollar of something. Now that sounds very much like jQuery, and that's precisely what it is. Casper.js allows you to inject any script into a page, and out here what we're doing is saying that whenever you create Casper.js, just make sure that jQuery.min.js, which is the current folder, not obtained from the internet, from the current folder, just put it into every page. So very cool that way. You can put in your worded voice to global, it does, yes, automatically. You can put an underscore, BP, sizzle, whatever. That works fine, but you cannot put in a URL, so this has to be in local. So we get this main table ID, and within that find all of the links. So that will get us the links for each of these states, and that then gets returned as an array. So we've got the IDs of the states as well as the names, which is the text of the states in this array. We then look through that and get a structure that looks like this. We effectively get the contents of each of those rows as data. So for Andhra Pradesh, we want the numbers 178, 817, blah blah blah. We just extract the entire row at one stretch, again using jQuery, and then write that as an output. Now I'm not going to be able to run that on this machine, am I? I could give it a shot and show you on my computer. Let's get the raw file and let's do that. Copy it into Notepad.
Aren't you going to need jQuery similar?
I'm going to need jQuery as well. So let's get jQuery. jQuery.min.js and copy that, save that as jQuery.min.js.
You didn't fetch
I run the risk of saving first. Now let's do here just.js and jQuery.js. If I say Casper.js .bat s.js, it might work. If it does, what you ought to see in a few seconds, let's get back to find.csv. I need one more module, which is the csv.js module, which let's see as csv.js and paste. See, yes, okay, now let's try it. Yeah, so what it's doing is saying that I've found 30 states. Now I'm going into the page that has the first district, in which I've found district 1 of 30, in which I found 0 rows. Okay, so something wrong with this paper. I'm sure there's some other dependency that I haven't put in, but normally this would be about 40 rows and then 70 rows and then so on. It keeps incrementally building. And this is being done on a weekly basis at the moment, live on an EC2 machine. Every week it scrapes, and we figured weekly is roughly the right duration to scrape that. That's when you get some sizable data. And that's being archived at archive.github.io, so where you'll be able to download this data. So for this data set, for example, you can download the file, and it's a standard CSV file in which you will be able to see for each of the states, for each of the districts, for all 600 odd districts they categorize it as, what is the total project outlay, what is the total share, etc. I just wanted to leave you with this code base. Like I said, it's on github.com/archive. Please feel free to take a look and play around with it. It's a reasonably simple and reasonably well structured example of how one can do multi-level scraping using Casper.js. Happy to take any questions.
Can this search be narrowed down? Like I had a hard time finding restrooms in MG Road, so it can be used like maybe a toilet finder app or something like that. Is it accurate?
There is no information whatsoever on the location of toilets. None whatsoever. There is this is a very, very deep problem. Okay, I mean, in the sense that on the one hand, no information is being collected about the location of the toilets other than the supposed addresses of the toilets, and this is being collected at a relatively low level, meaning at the ward level and the council of the ward level, rather than at even the city corporation level. That's problem number one. Problem number two: there are enough incentives to not create a fully functional toilet, and therefore, getting this information out of the wards, even the city commissioner admits that he finds it difficult to figure out where his toilets are.
Does it include all the, there's this Infosys sponsored toilets, right? Does that include that also?
If it is under the TSC campaign, it would. I don't believe that the Infosys sponsored toilets come under this. They are completely independent. There are a number of toilet schemes. Lots of people are going around creating toilets with good reason, I suspect. But yeah, this only includes the tsc.gov.in data, where it is updated. Like you saw, Andhra Pradesh versus budget is not updated since 2015.
Thank you.
Is there anything we can essentially use on the client side for scraping into iframes?
Okay, can we use something for client-side scraping? Absolutely. The easiest mechanism, in my opinion, would be a combination of YQL and jQuery. So YQL is the Yahoo query language. What that does is lets you pull data from pretty much any page and run queries on Yahoo's infrastructure. That's one way of doing it.
There's a limitation for YQL, right? Like
Yes.
10,000 hits.
Yes, so you run into that problem once you get to the landscape. The other way is, and this is something that I'm talking about, Internet Explorer with Python. The reason was there were some sites that would just work only on Internet Explorer. So this is a way by which you can sort of use the client side with some server side controls, and when it loads, I'll talk you through it. So what you could, okay, this is actually not using Python, this is using Perl. What you can do is use the mechanized module in Perl, using which you can actually create a new browser. Open up IE, the window physically, it'll open up, and use Perl to control it. Now, Perl is just an example, it could just as well be Python on the back end. And this is in fact a Python example. So you can start with the client and send a com dispatch. This will open up Internet Explorer, make it visible, make it go to video.google.com, and keep waiting until it has loaded. Now this is a very, very crude hack. There are better ways of waiting for IE to load the page. And then when it's done, get the document.body.index. So in this case, you're just automating the browser using server-side stuff, which is not too different from what you would do with Selenium, for example.
Ruby water also.
Yeah, or a whole bunch of tools. So yeah, client-side script could work that way.
Yes.
Thank you, folks, and
Thanks.